So next up we have division of polynomials, which we should have as a review, and that's kind of why it's in A.3. We should all kind of know how to do long division, but this should just be a quick refresher. Along with long division, it's important to know some of our basic factoring skills. So I've included this here just quickly. So we should know difference of perfect squares. So if we have x, let's say x squared minus a squared. To factor that, that is x minus a, x plus a. So if it was x squared minus 9, for instance, you know that's factored into x plus 3, x minus 3. Same thing with squares of binomial. So if you have x plus a quantity squared or x minus a quantity squared, this is what we've been working on with completing the square. That looks like x squared plus 2ax plus a squared. And if there's a minus sign in between, that's x squared minus 2ax plus a squared. For perfect cubes, we haven't really seen those in a while, but if you have x plus a cubed or x minus a cubed, that looks like x cubed plus 3x squared a to the first plus 3x a squared plus a cubed. And if there's a minus sign, then we alternate. So that's x cubed minus 3x squared a plus 3x a squared. Let's make sure that I did that right. Yep. And then minus a cubed, which makes sense. Next up, difference of two cubes. So you might have seen Mr. Murphy write that. So that's x cubed minus a cubed. And all these, a is just some number. So first you write it without the cube. So x minus a. Square the first term. Product of the two, change the sign. So plus ax, square the last, a squared. Or if you had x, yeah. So that's right. Product of the two, change the sign. Yeah. Last up, sum of two cubes. So we have x cubed plus a cubed, which would be, first write it without the cube. So x plus a squared, then x squared, product of the two, change the sign. So minus ax plus a squared. Those are our factoring bits. So those are all multiplying. With long division, I want you to think back to 5th grade when you were traumatized by doing long division. So I want to divide 842 by 15. So I write 15 on the outside, and I write 842 underneath here. So I go, 15 goes into 8 0 times. Okay, so that doesn't help. So 15 goes into 84. Well, 15 times 4 is 60. So 15 times 5 is 75. And then it would be 90. So we would say 5. So 5 times 15 is 75. And then we subtract. So this leaves me with 1. So 84 minus 75 is 9. Bring down the 2. All right, so 15 goes into 92. We just said 6 times. So 6 times 15 is 90. Subtract. So that gives you 2 left over. So we say remainder 2. That remainder that we talked about in 5th grade means 56 plus 2 over 15. That's what our remainder is. So if we did it again, let's just try a couple more. Divide 11 by 7. So 7 on the outside, 11 on the inside. 7 goes into 11 one time, which is 7. Multiply, subtract, so that's 4 left over. So 7 doesn't go into 4 at all. So we write a decimal, and we're going to add a 0. So 7 goes into 40 5 times. Then we multiply out 35. And this is how decimals are generated. So we're left with 5, add a 0. This would be 7, 49, which is 1. We're going to subtract, add a 0. That's 1, which means 7, which gives you 3. Bring down a 0, 4, 28, and then 2, 8. That's what it's going to end up. 1.571428, and then it repeats itself. Same concept. 27 on the outside, 386 on the inside. So 27 doesn't go into 3. 27 goes into 38 one time. So that's 27. We subtract these two. We should get 38 should get 11. And bring down the 6. So 27 goes into 16, I would say 4 times. So 4 times 20 is 80 plus 28, so that's 108. And we subtract, so 116 minus 108 is 8, which means our remainder is 8. So if that 14 plus 8 over 27ths, that's our mixed number as our answer. So if that helps you remember how we do long division with numbers, we're going to do the exact same thing with polynomials. So as a reminder, if we wanted to do this with any of the numbers that we had before, to check your answer, we take the quotient, which is our answer, times the divisor, plus the remainder, gives us our original number. So we're going to do this process of long division with polynomials. So we want to find the quotient and the remainder of this quantity divided by x squared. So we write x squared plus 1 on the outside. And then we're going to write 3x cubed plus 4x squared plus x plus 7 underneath our division sign. And then we say, what number multiply x squared times what number gives me 3x cubed? So that would be 3x, and I'm going to write that over the place value, and then we multiply both terms. So 3x times x squared gives me 3x cubed. 3x times 1 gives me 3x, and then I'm going to subtract. So when I subtract these, the first term cancels out, and I have 4x squared minus, see how I lined these up? These don't line up correctly. So that's minus 3x in the x column. So these cancel. I bring down the 4x squared. X minus 3x is negative 2x. And that I'm just going to leave the plus 7 for right now. So now I check. X squared times what gives me 4x squared? So plus 4. Then I multiply. So 4x squared plus 4, and then I subtract, and I do need to bring down the 7. So these cancel, negative 2x, 7 minus 4 is 3. X squared doesn't go into 2x anymore, so my answer is 3x plus 4 plus negative 2x plus 3 all over x squared plus 1. This is my quotient and remainder. And to check, to see if these give me the same thing. So this is my check in blue. I would do 3x plus 4 times our divisor, which was x squared plus 1, plus my remainder, so plus negative 2x plus 3. This is to check to see if I get the original. So if I FOIL this all out, 3x cubed plus 3x plus 4x squared plus 4 minus 2x plus 3. So if I put like terms together, I have 3x cubed plus 4x squared. This gives me plus x plus 7. And if you see, my original and these are the exact same. So I did all of the work correctly. So let's try a couple more together just to get the hang of it. So find the quotient and the remainder of this quantity divided by this polynomial. So I'm going to write x squared minus x plus 1 on the outside. I'm going to write x to the fourth minus 3x cubed plus, I'm going to leave a little space because I have 0x squared. And that's the trick with these. It has to go in descending order with the polynomial. Plus 2x minus 5. X to the fourth, x to the third, x squared, x, negative 5. So what number do I multiply x squared by to give me x to the fourth? That's going to be my x squared. So then I multiply and subtract. So x squared, that gives me x to the fourth. X squared times negative x gives me negative x cubed. X squared times 1 gives me x squared. And I'm going to subtract, which means I'm going to change all the signs. So the first terms cancel out. Then I have negative 2x cubed minus x squared, and I'm going to bring down this 2x. So next up, x squared times what gives me negative 2x cubed? So minus 2x, multiply, so negative 2x cubed plus 2x squared minus 2x. And then I'm going to subtract, which means I change all the signs. So these cancel. This gives me negative 3x squared plus 4x minus 5. And last off, x squared to get to negative 3x squared is minus 3. So then that would give me negative 3x squared plus 3x minus 3. And I'm subtracting, which means I change all the signs. So the first terms cancel out. 4x minus 3x is x. Negative 5 plus 3 is negative 2. This is my remainder. So my remainder is x minus 2 over x squared minus x plus 1. So that is my full solution. Could we check it using quotient times divisor plus remainder? Yes, and we would see that we would get the original. We got 2 more to do, and then we're done with long division. So example 4, we're going to do the exact same setup, only it's written as a fraction. So we have x squared on the outside. We're going to write 3x cubed minus x squared plus x minus 2. So to get x squared to 3x cubed, we have 3x, and then we have 3x cubed. That's it. Subtract. Those cancel out. I have negative x squared. So, and then plus it. So I could bring down these terms. How do I get x squared to negative x? Negative 1, so negative x squared. And that's it. Subtract, which means we change the sign. So we're left with x minus 2 as the remainder. So this solution is 3x minus 1 plus x minus 2 over x squared. So we basically reduced these first two, and then we couldn't reduce the second two. And that's why when you were a freshman and you were trying to simplify these, you couldn't just cancel out a couple of the x squareds from the top and bottom because we have this as a remainder. So last up, see if we can get any more challenging. We're going to write 3x cubed minus 1 on the outside. And I'm going to leave a lot of space because we have 3x to the fifth. And I'm just going to write plus 0x to the fourth plus 0x cubed minus x squared plus x minus 2. It's important that we have these two 0 spots because it's almost like a place value in our number system. So from 3x cubed to get to 3x to the fifth, I want to multiply that by x squared. And I put that over my x squared place value. Now I multiply. So x squared times 3x cubed gives me 3x to the fifth. And x squared times negative 1 gives me negative x squared. And then I'm subtracting. So that means I'm going to change the signs. So my first terms cancel out. These cancel out, and I'm left with x minus 2. So it turned out that these place values didn't matter as much. Now x cubed doesn't go into x any further, so that's my remainder. So my solution would be x squared plus x minus 2 over 3x cubed minus 1. And that's long division with polynomials. It's a little labor intensive, but once you get the hang of it, it's pretty easy. All right, so the problem set's at the bottom, and we'll work on this in class.